Hello everyone, I Sania, Faculty of BCA Department from Tecnia Institute of Advanced Studies. Today I am going to represent a lecture on priority interrupt. Let's start now. There are a number of input-output devices attached to the computer. They are all capable of generating the interrupt. When the interrupt is generated from more than one device, priority interrupt system is used to determine which device is to be serviced first. Devices with high speed transfer are given high priority and slow devices are given lower priority. Establishing the priority can be done in two ways, using software and using hardware. A pooling procedure is used to identify high priority in software means. Next is pooling procedure. There is one common branch address for all interrupts. Branch address contain the code that pools the interrupt source in sequence. The highest priority is tested first. The particular service routine of the higher priority devices is served. The disadvantage is that the time required to pool them can exceed the time to serve them in large number of input-output devices. Using hardware priority system function as all overall manager. It accepts interrupt request and determine the priorities. To speed up the operation, each interrupting device has its own interrupt vector. No pooling is required. All decisions are established by hardware priority interrupt unit. It can be established by serial or parallel connection of interrupt lines. Next is serial or daisy chaining priority. Devices with higher priority is placed first. The devices that wants the attention send the interrupt request to the CPU. CPU then sends the intake signal which is applied to PI, that is priority in of the first devices. If it had requested the attention, it placed its VAD, that is vector address, onto the bus and it blocked the signal by placing 0 in the PO. PO means priority out. If not, it passed the signal to next device through PO, that is priority out, by placing 1. This process is continued until appropriate devices is found. The device whose PI is 1 and PO is 0 is the device that sends the interrupt request, like shown in this diagram. Next is parallel priority interrupt. It consists of interrupt register whose bits are set separately by the interrupting device. Priority is established according to the position of the bits in the register. Mask register is used to provide facility for the higher priority devices to interrupt when lower priority devices is being serviced or disable all lower priority devices when higher is being served. Corresponding interrupt bit and mask bit are ANDed and applied to priority encoder, like shown in this diagram. Next is priority encoder generates 2 bits of vector addresses. Another output from it sets IST, that is interrupt status flip-flop. The execution process of the interrupt initiate input output is represented like shown in this diagram. This is the flowchart of diagram. I hope you understand the topic of priority interrupt. Like, share and subscribe Tecnia TV. Thank you so much.